So we need to make a triangle here. And so, like we did on the warm-up, if I didn't have this graph, if I could not count my x's, I could do 4 minus negative 3, right? We're subtracting them to find the difference. 4 minus negative 3 would become 4 plus 3, which would give us 7. And if you count this side, 1, 2, 3, 4, 5, 6, 7. That's correct. For my y's, I could do 5 minus 1, which will give me 4. And if you count right here, 1, 2, 3, 4. That's correct. So I could subtract my x's, it gives me a value. Subtract my y's, it gives me a value. And those are the lengths of the sides of my triangle. So now I can just do Pythagorean theorem with that. So 7 squared plus 4 squared would equal c squared. So 7 squared plus 4 squared is 49 plus 16, which is going to give us 65. And I could square root both sides. 8.062. That sounds right. So that would be our distance between 4, 5 and negative 3, 1. Okay, so we got this idea. We're subtracting the x's. It gives us a side for our x. We're subtracting our y's. It gives us that vertical side. And then we just do Pythagorean theorem with those two numbers, right? So let's think about what to do if I've got to find the distance between 45, negative 13, and negative 27, 12. Even if we had a piece of graph paper big enough, this one's not easy to graph, right? So let's think about that same thing. I'm going to sketch a really rough graph here. So negative 27, 12 is over here. And 45, negative 13 would be way over here. And we would be looking for that distance. So again, if I mark the x-axis here, this is my negative 27. This is positive 45. If I mark my y-axis, this right here is negative 13. Up here would be positive 12. So what I need to do is I need to go from 27 over here to 45 for my x's. Right? So to find the difference between those, with the picture I can kind of tell, well, this distance right here would have to be 27, and this would be 45, so I would add those together. But if I was just doing this from the coordinates, I could do 45 minus negative 27, and that minus and negative ends up adding those together. So 72. So that's the length of this side. And then for our y's, we would have negative 13 minus 12, which will give me negative 25. And because I know that the length of a side needs to be positive, I'm just going to call it positive 25. Or if you make it negative 25, it really doesn't matter. Because when I do Pythagorean theorem, I'm going to do 72 squared plus, if I do a negative 25 squared, which the negative is not necessary, I usually just leave it off because it will make you might type something in the calculator wrong. If I do 72 squared plus negative 25 squared, I'm going to get 5,809. And notice here, the reason that it doesn't matter about that 25, if I do negative 25 squared, or if I do 25 squared, I get the same number. It doesn't matter. What you will get wrong is if you do this. If you do 72 squared plus negative 25 squared, if you leave off those parentheses, you will get it wrong. You'll get 4,559. So it's best just not to use that negative at all. Just use a positive because the length of sides are positive. So if you get a negative number, just make it positive when you plug it in. And so we got that 5,809. We're going to square root 5,809. Oops. And we get 76.217. For our C. In general, I usually round things to 3 decimal places. If you keep more decimal places, that is fine. You may see on like worksheets or quizzes or something where it might ask you for something different. So round to whatever it says. But in general, if I haven't told you otherwise, 3 decimal places is your best bet. I do that because in AP Calculus, the test, everything has to be correct to 3 decimal places. So I think that's sort of a good idea to sort of like standardize everything. So I also do that in my classes for the most part. And on AP exam also, like if you keep extra decimal places, you're not penalized for that. You don't have to round correctly to 3 places. You could just keep all the decimals if you wanted. So that's also okay for me always, except sometimes if it tells you to round in Canvas, you've got to round correctly in Canvas or it's going to count it wrong. So in Canvas, make sure you round to what it says. All right, now let's talk about this. I've got to find the distance between x1, y1 and x2, y2. These are subscripts here. They're not squares or anything like that. They just tell us, basically this is telling us the first x and the first y, the second x and the second y is what it's saying. There. So, this involves 2 completely unknown points. We don't have numbers here. So, let's think about what we just did, right? Here, to find the distance between our horizontal side of our triangle, we subtracted our x's. For our y's, we subtracted our y's. And then we took these 2 numbers and we put them into the Pythagorean theorem. Right? So since we can't really graph this and since we can't really get a number answer for this, let's use that same strategy that we just used. So for our x's, we would just have x1 minus x2. Or if you want, you could do x2 minus x1. The order of those doesn't matter, right? Just like it didn't matter whenever we were doing the formula. And for my y's, I would do y1 minus y2. Again, that's just saying the first x minus the second x, the first y minus the second y. Those subscripts, that's all they mean there. Well, I don't have a number to put into Pythagorean theorem like I did for the other problems, right? But let's say that this I have in parentheses here is my horizontal side. So that's the length of the side. I need to square it. This is the length of the vertical side. So like if I am like thinking about what a graph of this looks like. And this is x1, y1, and this is x2, y2. When I subtract my x's, it gives me the length of this side. When I subtract my y's, it gives me the length of this side. So this would equal, I'm going to call this right here d for distance. So I'm going to call that d squared. Okay? Now, I want to know the distance, not the distance squared. So if I want to get rid of that square over here with this d, what do I need to do? Square root, right? Square roots undo squares. So if I square root both sides here, then I'm going to move the d over here to this side. D is going to equal the square root of x1 minus x2 squared plus y1 minus y2 squared. This is our distance formula. Oh, it's a hateful one. So, some students, I used to only teach distance formula. I did not teach Pythagorean theorem first. I did not show you how to do it from a graph. I just went straight to, here's the distance formula, memorize it, use it to find the distance between 2 points. Lots of students could do it, but as you may imagine, the problem is they're not going to give you that formula on the exam, and if you don't have it memorized, you don't know how to find distance formula. You don't know how to find distance if you rely upon that. So, I have changed how I've taught this where we start from Pythagorean theorem and do the stuff from the graph first, because you guys seem to be doing pretty well with that yesterday, and you already knew how to do Pythagorean theorem, so it related back to something you already knew how to do. So, you are welcome to continue to use the graph. However, I will guarantee you that you will get some problems with some numbers that are too large to use a graph for. Right? So you will see some like we just saw on example 2, where the numbers are just too big to graph. You're not going to be able to get like a precise graph where you can count for those. So you've got a couple options on what you can do here. You can do what we did on these problems where you subtract your x's to get this number, subtract your y's to get this number, and then do Pythagorean theorem. That essentially is what distance formula is. Or, other students, they just prefer just to memorize distance formula, right? Just to know that what the distance formula is, and you can just plug those numbers in, right? It does not matter to me which method you use as long as you can get the answer right every time. Okay? So tomorrow we will have a quiz just on distance between the 2 points. So all it's going to have on it is questions that say find the distance between 7, 3 and negative 4, 2. Right? It's only going to have distance formula problems on it. I am not going to give you the graph, but I will give you a sheet of graph paper that you can use to graph it if you would like to graph it. Yes. Yep, it'll It'll be a quiz grade. Okay. So I will give you a sheet of graph paper if you want to use graph paper. Or if you're like, that graph stuff never really made sense to me, maybe distance formula makes more sense and you can use it every time. Or you might be sort of in between where, like, if it's easy to graph, you'll graph it and use the graph. But if not, you would rather use distance formula. That's okay too. But the next few problems, I want to use distance formula so that you get a feel of what that looks like. So if we are using distance formula to find the distance between -4, 5 and 6, 7. So that distance formula, everybody make sure you've got that distance formula written down and written down correctly. All right, so if you did not write that distance formula down, you need to make sure it's written down, because I will be upset if you ask me, what's that distance formula again? And you don't have it in your notes. Okay, so what we're going to do here is we're just going to let this be x1, y1, and x2, y2, or you could switch that. You're just saying this is my first x, my first y, my second x, my second y. It doesn't even matter if you mess up the points on this. Slope is a little bit trickier. Like whenever we do slope, we do the same thing for slope, but we have a different formula. Distance formula is very forgiving. If you mix up your x1s and y1s, or x1s and x2s, it's fine. If you put the y's first instead of the x's, it's fine. As long as you got minus signs in between and a plus sign here, it's fine. So for this problem, my x1 is -4. My x2 is 6. So I've got -4 minus 6 squared plus my y1 is 5. And my y2 is 7. Now, you can type this whole thing into the calculator at once if you want. I would discourage you from doing that. Because if you do, most students usually mess up their parentheses and it turns out badly. I like to go ahead and do this. So -4 minus 6 is -10. And then 5 minus 7 is -2. I like to get it down to at least here. But most of the time, I'll just go ahead and do 100 plus 4. These two numbers you're getting right here should be positive every time. Why are they going to be positive every time? Well, yes, but distance does always have to be positive. So if you were... But that's not the reason these numbers right here, the 104, have to be positive. Zach? What? Right, when we raise them to the second power, they have to be positive, right? Because even if you have a negative number, negative times negative will give you a positive whenever you do that. So these two numbers right here should always be positive, and then you get square root of 104, which we will type into the calculator. Okay, so 10.198, like Julian said, would be our answer. Now you can, at the very beginning, do the calculator. Yes, you will have your calculator. And all answers will be decimal answers. You can do this from the very beginning in the calculator and not do those steps, but you must be careful if you do that. Because if you forget to close the parentheses, for example, if I type this in right here and I forgot this parentheses right here after the 7, I get a totally different answer. So I would be really careful. Also, like if you type it in at this point where you got the -10 squared plus -2 squared, I usually just type it in 10 squared plus 2 squared. But if you use negatives, you got to do negative 10 squared plus negative 2 squared. If you're squaring a negative, you got to have those parentheses or the calculator cannot do it correctly. Okay, questions? Okay, we've got us another perimeter of a triangle problem. Perimeter of a triangle, remember, is an evil problem created by math teachers to make you have to do 3 problems in one, right? So if we need the perimeter of a triangle, we need to know the length of all of the sides. So look, we're going to do this one with distance formula, not with graphing like we did yesterday. You can use a graph. Tomorrow's quiz is just a really quick, do you know how to do distance quiz? So you probably won't see this on the quiz, but you'll definitely see this when we get to like the tests. So if I'm going to look at AB first. Okay. So I'm going to use distance formula. Let me write it down here. All right, so let's see. Hank, tell me how to plug in my numbers for AB. For my A, it's going to be that. We can let that be my X1, and then this is my Y1. So first coordinate is X, second coordinate is Y. And then for B, you could let this be your X2, and this be your Y2. No. Minus negative 7. Okay. And make sure you still got plus sign in between, squares for each one. So negative 4 minus negative 7, that becomes a plus 7. So you will get 3 squared, and here you will get 5 squared. So 3 squared plus 5 squared. That sounds wrong. So what I've done here, like your parentheses would be around the 3 and around the 5. So it should just be, it should be 34. 3 squared plus 5 squared. So square root of 34. And in fact, I am going to leave this right here, AB. Okay. It's just going to equal the square root of 34. I can get a decimal if I want. I'm just going to leave it. And the reason is, if you round something wrong, it might mess it up in the end. So I'm going to leave that. All right, now I'm going to back up. I'm going to do BC. I'm going to do the same thing for BC. So Wade, tell me how to plug in my numbers for BC. Yep. Great. So this is going to be negative 7 squared, and that'll become a plus, and I'll just have negative 1 squared. So it's going to be 49 plus 1, so that's going to be square root of 50. And again, I'm just going to leave that as BC for right now. If you wanted to, you could get this. What's the last side? Because that's only 2 sides. I need one more side for a triangle. AC. So for AC, here, Zane, tell me how to plug in those numbers there. Okay? Let's let A be our x1, y1, and C is going to be our x2, y2. Minus 0, because you're always using the minus sign there in between these. Okay? Good. So for that, this is going to be -4 squared. And then 2 minus -2, that becomes a plus. So that gives us 4 squared. Oh, I know what you've done. He says 0, but that can't be right. Because the only way it could be 0 if they were exact same points. But I know what Julian has done. He typed it in like this. Didn't you? And it did give you 0. But if you're squaring a negative, you've got to have parentheses around it. Positive number, it doesn't matter. You can put them for both of them, but it has to be there for the negative. Or, what I do is I just don't type in the negatives. I usually would probably just do this in my head, 16 plus 16, which is going to give me square root of 32. All right, that's our AC. You got to be really careful with those negatives in the calculator. It will be the downfall of most of you that miss them. So, even though it takes a little bit longer, sometimes I encourage you to do it by hand up until the end because you're less likely to make those mistakes in the calculator. All right, so then I've got these 3 sides. So then I usually do it like this. Square root of 34 plus square root of 50. Make sure you close your parentheses for these. If you don't close your parentheses, it will be wrong. Or if you have one of the calculators that has the newer operating system, you just have to hit the over arrow so you're not underneath the square root anymore. And square root of 32. And 18.559. Okay, questions? All right, so today, I do want you to try to do all of these questions that you're going to get without a graph. It is up to you. If you want to use distance formula, you may, or if you want to do like we did in the beginning where we just like subtracted our x's, subtracted our y's, and then did Pythagorean theorem, that's fine also. But I do not want you to graph these today, okay? Because you will get some numbers that are too big for you to graph. Now, the ones on the worksheet might not actually be too big to graph, but you will get some, so we need to do some practice without graphing.